Hi, welcome back. Remember when we started the session, we asked the question about how a pilot would know in which direction to fly his aeroplane? Let's get back to that question. So, here's a problem faced by our pilot. He wants to fly due east. In other words, he wants to fly to B, to the destination at B, but there's a strong wind that's blowing at 100 kilometers per hour in a southeast direction, that way. If the plane has a cruising speed of 450 kilometers per hour, in what direction should the pilot fly to reach his destination? So direction means we're talking about angle. We're talking about theta. So what they're asking us is, what direction must the plane fly in order to reach his destination at B, taking into account the wind force coming in that direction at him? Okay, so let's look at this diagram a little bit closely. Right, what are we given in this diagram? So, we're given this angle 45, so we're given one angle, and we're given this side 450 kilometers per hour, and we're given this side 100 kilometers per hour. So, we've got two sides and an angle. Can we use the sine rule? Do we have one pair and one half pair? There's our full pair, okay? We want to find theta, and we have the side across it. So yes, we can use the sine rule. Right, so let's write our equation, set up our equation using the sine rule. And again, which version of the sine rule are we going to use? Because we want to find theta, we're going to start off with the version that has sine theta in the numerator. So sine theta over the side across from theta, so it will be 100. We'll substitute this 100 in, and we will use our other full pair, and our other full pair will be sine of 45, this angle here, over 450. Now, we've got to just do some algebra to get our sine theta on one side, and we multiply throughout by 100. And then, because we're finding theta, we're going to use the shift function on our calculator, and we're going to find the value of theta and round off our answer to 2 decimal places. So we end up with an answer of 9,4 degrees. So what does this mean in the context of our problem? It means that this angle is 9,04 degrees. So, in which direction must the plane fly? In other words, the plane needs to fly at an angle of 9,04 degrees north of east. So basically, that way, at an angle of 9,04. Okay. If we did try and do a checksum again to see if our answers look correct, 100 is across from 9,04, and 45 is across from 450. So obviously, we did expect our answer to be significantly less than 45, which was the angle across 450 degrees. So in the context of that, our answer does look correct. Okay. Now, we've completed with all the formalities of the sine rule. Let's do a quick summary to recap what we've done thus far. What is the sine rule? So the sine rule, using triangle ABC, is a rule that states that sine A over A is equal to sine B over B, which is equal to sine C over C. And remember, there is a second version to this. This version we use when we are trying to find our angles, because our angles are in the numerator. Okay? And the second version of the sine rule we've used is this version, the reciprocal version, where all the sides are in the numerator. Okay? And we use these whenever we're trying to find the length of one of the sides of a triangle. It just makes our calculation easier, and this version reads A over sine A equals to B over sine B equals to C over sine C. Right. Again, let's revise when we use the sine rule. So we've made a bit of a rule that we said you're going to use the sine rule when you're given one full pair of angles and sides and one half pair. So another way of stating that is we either use the sine rule when we're given two angles and a side, okay, or when we're given two sides and an angle. What's important about this is that angle is not the including angle. Okay, so basically when we're using the sine rule, you can use any full pair and any half pair. So if I wanted to find C, I need to be given angle C and any other pair along with it. Okay, so we've almost reached the end of our lesson for today, where we dealt with the sine rule. Let's do a quick recap on what the sine rule is and how it's used. So the sine rule for any triangle ABC is sine A over A equals to sine B over B, which equals to sine C over C. This version of the sine rule we use predominantly when we're trying to find angles. So if we want to find an angle, then we will use this version because the angles are in the numerator. The second version of the sine rule we have is little a over sine A equals to B over sine B, which equals to C over sine C. This version of the sine rule has all the sides in the numerators, and we use this version when we're trying to find the sides of an angle. And when we're deciding which pair of these equations we're going to use, it will be determined by what has been given. So let's look at an example again. When do we use the sine rule? We use the sine rule when we're given one full pair. So in other words, when we're given a set of angles and the matching side across it. Okay, and when we have one half pair. So in other words, we can use the sine rule either when we have angle, angle, side, or when we have side, side, and angle. But remember, we don't use sine rule if we have the including angle. So sine rule is used when we have side, side, angle, when not the including angle is given. So for example, again, just to recap, if we're given that as our full pair, we're given B and little b, and we want to find, for example, little c, then we have to be given the rest of this half pair. In other words, we need to be given angle C. So sine rule kind of works, if you notice, in a bit of an X fashion. So we need one full pair, and we need one half pair. Okay, that brings us to the end of our session, and so far we've covered the sine rule today. We've done that. In our next session, we'll be doing a little bit more on the sine rule and touching on a bit of, we'll be introducing the area rule as well. Okay, so I hope you'll join us next time. Thanks. Bye.